We are going to start our course on software engineering, where we will try to understand what a software is and what are the good practices to make a software right. Okay, so in this course we will be referring this book from Roger S. Pressman, Software Engineering, a Practitioner's Approach. So this is a slide I have taken from there only, from Roger S. Pressman. This is the exact things which are there in the book. So throughout this course, what we have to do, we will go through the concepts. You will have to also read the book, because in book you will read more than that we will see here in the video. After that definitely we will have our examinations to see your performance. So today definitely we can start with what a software is. So we call a software as sometimes when you will ask when I will ask you people, you will say it is a set of instructions, set of programs, something like this. So definitely when you call set of instruction, or I should say sequence of instruction, it is a program, right? When you have multiple programs, they are working together for a common objective, we call it a software. But we should not forget this data structures which are being used there, and the documentation which may also be important. So when we are talking about software, we should consider that definitely the programs which we have created, along with these programs, the data structures that we are using, along with that the documentations which are there to describe the operations and the proper use of the programs. So this is something about software. Do you want to hear something more about the software? Any confusion till now? No, sir. Okay. So here we are thinking about what a software is, right? So in a sense we have understood till now that there is a software. It is definitely a logical thing. It is not a physical thing. Okay. It is means okay. So we have to know something more about the software to understand it properly, I believe. So if we move further, there are three things that we are going to discuss here. One is software is developed or engineered. It is not manufactured in the classical sense. Okay, so here what we have to understand, maybe sometimes it may look like that hardware manufacturing or software development, those both are looking something similar, right? But they are actually different, right? How they are different? Because see, manufacturing phase of hardware can introduce some quality problems. These kind of problems may also occur in software, no problem. Okay, but in the next point I will tell you something about how it is different from hardware development, but hardware life cycle. But here I will tell you that relationship between people applied and work accomplished is entirely different. Okay, people those who are working there, and what the output is coming. In manufacturing phase, it is very much verifiable. However, in case of software, it is not exactly as it is in manufacturing phase, because in manufacturing it is totally physical thing, right? However, here it is a virtual thing. So here we are talking about the second point. If it is saying that software doesn't wear out. Software doesn't wear out means software is something which is at sometimes it is okay. Let me show you a graph here. We'll come back to this slide, but this is a graph which is showing something about wear versus deterioration, which means actually this is just graph or software. However, for hardware, what happens if at all it is visible here? Wait a minute. In case of hardware, from here, this is the life cycle of the product. If it is a hardware, starting from here, it will have certain defects. These defects will be corrected, right? So these failure rates will drop, and eventually it will be idealized. But after some time, when there will be certain effects of environment, maybe dust, vibration, temperature, or several other things, it will what happens, the faults will start occurring. Okay, some of the problems will arise in the hardware, and from here the graph will again go up. Okay, which means after certain time, because of environmental issues, it is for hardware, the hardware will start showing more faults. Okay, because of that, this is this phase where it will start showing more faults. In that case we call this as wear out phase. Okay, so let me also tell you that in beginning, in case of that manufacturing thing, or in software also, this phase where this is initial failures are occurring and we are correcting it, this phase is called we call it infant mortality. However, later on, when in last phase of this product, these new failures are coming, after that correcting this hardware is a really difficult thing. This phase we call it as wear out phase, where this hardware is is not usable anymore. So this was the story of hardware. However, in case of software, what happens? It doesn't wear out. So if it doesn't wear out, means it is not affected by environmental issues, right? So in that case, this is the idealized curve that should happen. Initially, definitely certain faults will be there. We will correct it, and the number of faults will decrease. And by time, there will be an idealized portion where the number of faults will be stable, and it will be very low. Okay, this is what we think. But actually, what happens in case of softwares? We always get some change requests. Okay, definitely initially we decrease the number of failures and bring it to a minimum, maybe still above the expected, but okay. But here we were expecting that the line will be parallel to the axis, which means it will be stable it will not have more faults now. But actually what happens, a change request comes and we perform certain kind of changes in the software. Since we perform new changes in the software, because of that the number of faults increased, and then we perform certain corrections and modifications, and the number of faults decreased. Now when the fault decreased, now from here we expected that it will idealize, but what happened, again a new change request came. With this new change request, some more faults are coming, and with this fault we are tolerating it, and in this way what we find, as from here we expected that it will be idealized or it will be stable from here, but actually the number of faults keep on increasing. This actually happens with our software development. However, we actually try to maintain this thing, that whenever change is going on, we will manage it nicely, that it should not affect much on the total software, right? The part of the software which is being changed, it should change and others should not change. So this is something about we are talking about, that the software doesn't wear out. It is not that a certain time will come and it will decay because of environmental issues. No, that doesn't happen. But still it deteriorates. The software doesn't wear out but deteriorates. By the time the new change requests come, and it keeps on deteriorating. But with good practices of software engineering, we can reduce this effect. Now let me come back to the slide, where the third thing we were talking about is, although the industry is moving towards component based construction, most software continues to be custom built. Here we are talking that software development should be designed and implemented so that it can be reduced in many different programs. Okay, so reusable components are there, which will definitely help to make new softwares. But nowadays it is also true that many new requests for softwares are coming, where new design, new things are, new programmings are required. But still, this is also true that the reusable components have helped the software engineers very much, where we can make a design, make a component, make a software module and reuse it in another software. So it is really helpful. Now we are trying to understand, let me move further. We are trying to understand the software applications. I should say it can be understood as categories of computer softwares, based on their application. This thing you can understand. So till now, if you have some questions, you can ask. Do you have some questions? Am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So you don't have anything to ask, which means you have understood that okay, software is something where it is a set of programs along with the data structure and documentation, right? And also you have understood that the software is developed, not manufactured. it doesn't wear out, and also it deteriorates, है ना. Also the component based construction is there, which is helpful, but also custom built requests keep coming. Now here we are trying to understand the applications, okay, categories of software based on applications. So you understand one is system software. I believe these are the terms that you would have encountered till now, but still let me say something about these, or shall I ask you something about this, what a system software is, application software is. These are a few things I believe you will understand. Okay, let me ask it is Lokesh Kumar. Lokesh,
Yes, sir.
do you understand what a system software is?
No, sir.
Okay, application software.
No, sir.
Okay, very good. So it's okay. Now it seems that some of the students are there where to whom I can explain these things. So system softwares are just a collection of programs written to service other application programs. Okay, these are the set of programs, like it may be compilers, some other file management utilities. Okay, these are certain kind of softwares which help other programs to use their utilities. Basically the system softwares are the one which can interact with the hardware directly. Okay, like the main example of system software, you can call it as operating systems. Okay, the operating system components that they will be considered as system software. Why? Because they directly interact with the hardware and they make an environment where we can run our own programs or our own application softwares. So these operating system components, or maybe some certain kind of drivers that we use which directly interact with the hardware, these all can be considered as system software. Okay, now what is the application software? Application software can be considered as a program that solves a specific need of your institution, your business. Okay, so this application software does not need to interact with hardware. Okay, it is a simple software which will run on another system software. Maybe it will run on a operating system. So here we are talking about a software which does not interact with the hardware. It is just a software which runs on the system software like operating systems. Is it clear about system software and application software?
Yes, sir.
Lokesh, you said
Yes,
you
sir.
didn't know.
Yes,
Can
sir.
you understand this?
Yes, sir.
Okay, so if you have understood, I will ask you about what a system software is. Can you tell me?
Yes, sir.
Tell me.
System sys- system software, sir, direct interact with the hardware.
Okay. Example?
Operating system, sir.
Any example of application software?
Sir, any apps वगैरह.
Okay, any apps वगैरह. So this is something about system software, application software. What engineering or scientific software may mean. Okay, engineering software or scientific software, here they have categorized it like those software which are using scientific algorithms, okay, involving high computation on data, and maybe especially designed for this scientific purpose. Okay. Okay, so this was engineering and this kind of software. Suppose certain things for we may call it software designed for space exploration, or even those softwares of computer graphics which are being used in scientific purpose like CAD. You would have heard about computer design, or maybe different kind of simulators that are working for a scientific project. They all will be considered as engineering and scientific softwares. Now here it is embedded
Excuse me,
software.
sir.
Yes.
Sir, is MATLAB a scientific software?
Yes, MATLAB can be considered as scientific software.
Sir,
Basically,
it does
this.
not needs to.
Ajit.
Sir, software does not needs to do high computation like MATLAB, right?
Which software?
Like MATLAB, sir.
MATLAB can do high computation, no problem.
Sir, it depends on PCs, no, sir. Configuration of PC.
Yeah, definitely it may depend. The thing is, these engineering or scientific softwares are also application software which definitely run on a particular computer, but they are especially designed for scientific purpose. This is the thing. Okay. Now there is something called embedded software. Embedded softwares, I believe you may understand that nowadays several embedded machines are available, right? You may have seen a microwave oven where certain keypads are there. You will see definitely a calculator may be also considered as embedded device, and several other things where a program is embedded in it. Vedanta is saying ATMs. So ATMs actually, I will have to understand. Somebody was telling me that there is a computer inside where a program is run and the output is shown in monitor. Just the monitor is touch screen. So I may face, but definitely the keyboard of that particular ATM will have to be embedded software, because it should have its own different processing component which will take the input and send it to the processing unit wherever if it is. So such kind of softwares, such kind of hardware and software mixed devices will be considered as embedded devices. There embedded softwares are used. So even whatever examples nowadays, in all the things we are trying to insert a particular chip and to make it communicable with other devices. So all such devices can be considered as embedded devices. Okay, all such devices which are being made intelligent, they all are embedded devices. Basically, one more thing that we have to consider here, that embedded devices will be such devices where the programs cannot be changed. Okay, once the programs that we have fed it, that program is the only one program which will keep on running on that device. So those are embedded devices, and the softwares being used there will be considered as embedded software. Now here we call it something called product line software. You can consider it as the softwares designed for a specific need, maybe which provides a specific capability for use. Okay, and it is a product line software, which means it may not be a general purpose software. It may focus on a part of population, like suppose you would have heard about this thing, Tally. Tally can be considered a product line software, which will be helpful in to those people, those businessmen only. Okay, so such softwares can be considered as product line softwares. And not only these, some certain other softwares like database management softwares or any other multimedia softwares which are targeted to certain audience, that these kind of people, certain animation making softwares. So those people who are interested in making animation, they will only use such software. They can be considered as product line software, which are focused for certain kind of people. Now it is web apps, web applications. So we all understand web applications nowadays. What happens? We have our applications on internet, where there is a server and clients may access the resources from a distance. These web apps are also providing interface, and nowadays a better interface to interact with the system. This system, where they are on the server, they will definitely have certain capability of storing data, and through a graphical user interface that is being provided to the clients, using it and the network capabilities, we can access the resources like data or certain other computed informations. So these are certain things which are available with the web applications, and nowadays actually we are trying to have more and more web applications. Now AI software, artificial intelligence software, we can understand those kind of software which are using which are giving the software a kind of intelligence. It may include the robotics or any other kind of software, like where we are using pattern recognition in images, voice, or even in written scripts, or maybe other kind of machine learning algorithms, or certain games are there which can be considered as AI softwares. So such kind of things can be considered as AI software. So I was telling you, these are certain categories of softwares on the basis of their applications. So do you have to ask something till now? No problem. Before moving further, let us see some new categories nowadays. We have say open world computing. Okay, nowadays it is not just a standalone servers. Now we have distributed servers where we store our data in a distributed manner, and which looks like a single computer to the clients. So client can interact with this kind of servers also. Other is ubiquitous computing, where small devices uh, can communicate with each other. Such can be wireless devices. Such small devices can also have power of computing a little bit. So if at all a large computation which cannot be done by any one of the device, in that case that computation can be shared by such a small devices, and they all can together work on it and produce the desired result. It is net sourcing. This is a you are giving your resource on internet that others can use your resource. Such kind of things are possible now. Some softwares, definitely we are considering them as open source softwares, which are free to use by all of the others. Sometimes certain softwares we try to categorize like data mining softwares, which are especially for that purpose. Grid computing softwares, cognitive machines, or software for nanotechnology nowadays. These all are something which are being which are can be considered as categories of softwares. So these are something that we software engineers should keep in mind before moving further. That okay, different kind of softwares can be there with which we may have to deal with after completion of our degree. But the important thing is all these softwares, if they are developed in a haphazard manner, it may lead to a disaster. So we will have to study these software engineering principles to make a good software. Okay. So when we will move further, we will try to learn the steps in which we should make the software. It is not that we just got a requirement that this is the thing that we want to make a software and we started coding. This is not that we do in software engineering. We go through a step by step fashion, where there are certain steps that what we should do. We will learn these steps, that first of all what should we do, and then what should we do, right? Here let me tell you something about the legacy software. Do you understand what a legacy software may mean? Anybody, if they can say something about.
Sir, it runs on old architecture like 32-bit.
Okay. Others, anybody else want to try? So it is just an old system that you can say. Okay, old software I should say. Legacy software, legacy means very old. Okay, so suppose 20 years, 30 years back such kind of softwares were developed. 30 years, 40 years, whatever you think, such kind of softwares were developed. So in those days the softwares definitely may have developed for a limited resources, which can use the limited resources, right? Now we have plenty of resources and on a cheap cost, so definitely those softwares should be adapted in this new computing environment or technology. So for that purpose, we should be aware of this legacy software. So in a nutshell, if I have to say something about legacy software, so these are the softwares which were developed, I should say 20-30 years ago, and in these 20-30 years we understand the life cycle of a software. New changes keep on coming, so whenever a new change request comes, we will have to change the software. So from 20-30 years, if at all this software is being used, so there will be several changes that we have performed in this software. So as the number of changes will increase in the software, we know that the software also deteriorates. So these are the few things that we have to keep in mind. And now as we understand these legacy software, one more thing is that it is not that we can leave this software and use any other new software. If it would have been, we would have done it very earlier. But since such kind of softwares which are 32 years old but still are very important for organization, I should say the core process of that particular organization. So such softwares are important for the organization. So we must enhance and implement new business requirements with this particular software. So knowing this thing that legacy softwares are there and we will have to work with it sometime, and evolving such softwares are very risky, because you understand it has already deteriorated in such a long time, and now if you are working on it, you are changing something, definitely it may lead to new faults. So these are the few things that we have to understand. Software must be extended to make it interoperable. Software must be re-architected to make it viable within a network environment. So such kind of things are there which we have to keep in mind. Anything that you want to ask till now? Okay.